Kanishka, you should start now, no? Hmm. Actually, I was teaching you. Acha Kanishka, did you see this last class? You were there in the last class, no? No. Diva,
Yes, sir.
did you see the last class recording?
So I will see it tomorrow.
Or acha, just tell me, do you know what is the basics of gravitation?
Yes, sir. It is finished in VMC.
Basics, you know, na? So we are
Yes.
actually starting from the field due to continuous mass distribution. Sorry, PM may be joining now, but you have not joined by now. Oh no, what happened? Field due to continuous mass distribution we were doing, means the integration part we will do now. Acha, before that, acha, I have told you know about fields also, no? What is field? How do we get what is field? What is force?
Yes, sir.
Okay. Now see, first I'll take case of the simple rod. This is a rod. Okay, in which whose length is L and the mass is capital M. You have to find out the field at a point P. Do you know, Diva, how to calculate? Did they tell you this one, VMC?
So they only gave the formula.
Acha, they only gave the formula. Na? Now, see, let me tell you how do we do it. We actually know how to find out the field due to a point mass. That's G capital M by R square. In this case, the information given to us is the length is L. This length is L. And this is at a distance of R unit from P. The center of the rod is at a distance of R unit from this P. What we'll do here, we'll take an element, this element of length dx, assuming this is at a distance of x unit from P. Okay. Now, can you tell me, any one of you, can you tell me what is the mass dm? What is the mass of this element? Anyone? Diva, Kanishka.
Capital MD.
No. It's capital M by L into dx, because see, for length L, the mass is capital M. Now for the length dx, what will be the mass? M by L into dx, correct?
Yes, sir.
Like this you have to do. So now due to this mass dm, what's the field at P? It will be G dm by x square. It will be G m by L dx by x square. Now to find out the total field at P, we have to integrate this part. dep integral gm by L dx by x square. What limits you will put? X will be starting from, this is x. X will be starting from what? R plus L to R minus L. Okay. You know, no, this distance is actually R plus L. This is, no, not R plus L. It is R plus L by 2. Now it's correct. R plus L by 2, R minus L by 2. So the total field P will be Gm by L minus 1 by x, R plus L by 2 to R minus L by 2. So the value will be Gm by L minus Gm by L into 1 by R minus L by 2 minus 1 by R plus L by 2 minus Gm by L. It will be L divided by R square minus L square by 4. L get cancelled. So you will get Gm by L square minus 4R square. This is the formula, na? No, 4Gm by L square minus 4L square, 4R square. This is a field at P. Tell me, did you understand? And if any one of you have doubt, can tell me.
So I wanted to ask one thing, like what is the difference between what we are finding right now and the center of gravity?
Center of gravity.
I remember that when they told us center of gravity, it was something like this only, like we integrated it and did something.
No. That's Gauss law. Center of gravity is the center of mass, na? Center of mass, you are saying, na? Center of mass.
Yes, sir.
They both are different thing. Actually, the way is same, but the both things are different. Both the things are different because in the center of mass we actually assume different masses are there, elemental mass, and for each masses assume at a distance x, we use that one to find out the where is the center of mass located. And here we are trying to find out what is the field due to this whole rod at a point P. See, if you ask me the difference there, if you remember what we have done in that case, we have assumed, see, I'll write it here. In that case, we have assumed there is an elemental mass dm at a distance of x.
Yes.
So we have integrated dm into x divided by integral dm. This was x center of mass. For trying to find out the position of center of mass. But here we are trying to find out the field at point P. So we have found out the field due to this elemental mass dm at a point P, and then we have integrated. Integrated means we have found out the field due to each such elemental mass at point P, and then we have added them. Okay, there is a huge difference between this. Though even though the process is same, process looks like same. Understood?
Yes.
Oh. Achha, can you tell me now? What about Kanishka? Kanishka, okay?
Yes, sir.
Achha, now tell me this formula. Field. What will be the field due to ring of mass? How will you find out? What's the situation? I'll tell you. What is this? What is this happening? Hmm. This field due to ring of mass. Let me draw the diagram first. There is this ring. Hmm. You have to find out the field at a point P, which is at a distance x from the center. The radius of the ring is r. Total mass of the ring is capital M. You have to assume this as, you have to understand this as there is a ring on my hand, and perpendicular to it there is a distance where you have to find out the field. Think and then tell me. क्या वह नहीं हो पा रहा क्या? See how you will do. Again, you will have to assume a mass dm, but if you want to find dm, you can find out dm, but there is no need. How you will find out dm? For 2 pi r length, the mass is capital M. So for the length of, if you take dx, this, the mass will be m by 2 pi r into dx. You will know why I'm saying this is not needed actually. Just assume this as masses dm only. There's no need to find out this. Due to this mass dm is actually at a distance of root over x square plus r square. Now, due to this, there will be field in this direction, dE. dE value will be g dm by root over x square plus r square whole square. Correct? Yes, Diva?
Yes,
Tanishka?
sir.
Okay. Now, see, due to the lower part, if you take the similar element lower, due to this also there will be field in this direction also, and the value will be same. So if we take the vertical component, they will cancel each out. dE sine theta and this dE sine theta will cancel. They will cancel. So we actually need only the cos theta component of dE. Correct?
Yes, sir.
So we'll do dE cos theta for this dm, which will be g dm by r square plus x square. Cos theta is what? X by root over r square plus x square. So it will be g dm into x by r square plus x square whole power 3 by 2. Now to find out the total field, you have to take all the masses. You have to integrate this thing. But the good thing is, whatever elemental mass you take, whether this or some other place, every mass is actually at a same distance from the point P, that is root over x square plus r square. Right? You're able to see, because you have to visualize this ring in this way. The ring is like this, the ring is circular, and the point at which we want to find out the field is perpendicular to the plane. Correct? Yes, Diva? Tanishka?
Sir, so if we have such kind of question in maybe JE Advanced, then it's better to derive from starting, like
No, it
because
depends. No. It depends actually, Diva. It depends. If the question can be solved using just applying the formula, you can use the formula only. But if they have given something, if they have changed something, they have given some mass density, the mass density is variable and it is depending on the radius r, like that they have given, then you have to integrate. Then you have to follow this process. That's why I'm telling you this process.
okay, sir.
I'll see if this kind of question is there. I'll find out and then I'll give you. Don't worry. Okay. This process, why I show these processes, na? Actually, they gave you formula, but these process why I show, because these sometimes in advance, if they change something, na, mass density or something, then you will be stuck. So to find out, actually what I was telling, every element is actually same distance from this point P. So the total field integrating, if we do T cos theta, which will be E, it will be gx by r square plus x square whole power 3 by 2 integral dm, means all the mass, and integral dm means adding up all the masses will give us total mass. So gmx by r square plus x square whole power 3 by 2 is the field at point P, and it is towards the ring. Understood, or is it confusing? Kanishka is silent. Either she's sleeping or she's finding it a bit confusing.
Oh, sir, I am listening.
You're able to understand this one? Deva, तुम बताओ. How is it?
So it is similar to what we did in center of mass. So
Hmm.
it's less difficult than before.
It's good that you are able to relate with the center of mass. The difficult part will come now. Difficult part is if I ask you to find out field due to a ring, field due to a disk. There, this I won't ask you. I will just teach. Just observe how I'm doing it. See, this is a disk. This is your disk. It's whole solid, total solid. I'm not able to draw actually, but assume this is totally solid. Now, we have to find out the field at a point which is at a distance of x unit from it. Correct? Now, what I'm going to do here, I'm going to assume rings. Just let me set it. I'll make it copy. Okay. ठीक है दीवा, मैंने यहाँ पर किया क्या, मैंने यहाँ पर इसको फील्ड निकालने के लिए मैंने यहाँ पर ना रिंग लिया. मेरा कॉन्सेप्ट क्या है, मैं क्या करना चाहता हूं कि आई विल टेक दिस रिंग which is of radius small r and thickness dr. Thickness is dr. Correct? Now, because I know because of a ring, the field at a point P is towards the center, and its value already I know. If I have assumed this mass is dm, the field at P will be what? dp. Towards the center, it will be g dm by small r square plus x square whole power 3 by 2. Can I say? It will be difficult for you to understand, but because you have to make sure that just write this formula. I have derived this formula. Na? Achha, I have done one mistake. G dmx by r square plus x square whole power 3 by 2. Okay now?
Yes, sir.
Now what I have done, because of this ring of thickness dr, I have found out the field at P, which is dE. Now what I will do, I will now add the field at point P due to all such rings and make it a disk. For that, what I'll do, first I have to find out a dm. How I'll find dm? Because it's given the total mass of the disk is m, means for pi r square area, the mass is capital M. So the area of the ring is 2 pi r into dr. The mass will be m by pi r square into 2 pi r into dr. This is dm. Okay, pi gets cancelled, so dm will be 2mr dr by कैपिटल R स्क्वायर। ये ठीक है दिवा? ओके है?
Yes, sir.
तनिष्का ओके है ना?
Yes, sir.
ओके। तनिष्का की आवाज चेंज कैसे हुई? तनिष्का तुम सो रहे हो?
नहीं सर, मैं उठी हूँ। समझ गए।
तो
मेरी आवाज खांसी की वजह से ऐसी हो रखी है।
अच्छा, खांसी हो रही है क्या? ओके।
सूखी खांसी सर।
ध्यान रखो, ये सीजन चेंज हो रहा है, ध्यान रखो अपना। ठीक है, दिस वन, this is DE actually we have found. So now to find out I will have to integrate it. So I'll write this expression 1 here below. DE is equal to 2gmxr dr by r square into r square plus x square whole power 3/2. Now see, this is a complex integration, not simpler one, but I'll make it simple. Just look how I'm doing it, doing integrating, because this kind of integration is not yet introduced to you. R is variable. We say what is variable? R, because it is inside R, it is inside D. So 2gmx by capital R square will come outside. R dr by r square plus x square whole power 3/2 will be inside the integration, because I'm integrating small r from 0 to capital R. Okay. Now the interesting part is integrating this. Now to integration is not difficult, but this is somewhat different, which is not introduced to you. Here I will assume something. This is integration that we do by assuming something. Here what I do, r square plus x square I take as t. So 2r dr is equal to dt. So I'll bring inside. Gmx by capital R square dt by t power 3/2. See how easy it has become. Gmx by capital R square t power minus 3/2 plus 1 by minus 3/2 plus 1 0 to R. तुम लोग अपने क्वेश्चन बचा के रखना, because I know you will be having doubt, sir, what is this, how you have done. What is t? T is r square plus x square. So the answer I'm getting is 2gm by r square 1 minus x by root over r square plus x square. This is the field at point P. अब बताओ, now tell me what doubts you have. What all doubts you're getting? Bolo, Diva, tell me.
Sir, I'm still processing this.
Process it and see where the points where you have doubt. I don't think you guys may be having doubt till this equation. This is this first equation. You don't have any doubt till first equation, no? This one.
No, sir.
Acha. Now, do you have doubt when I have put? Acha, no. No. I have written the same equation in the here, pink one. Now, after this, I have done the integration, because integrating means I want to find the field due to all the rings at point P. Okay. Now, when I want to find the field due to all the rings at point P, I have to integrate. And when I'm integrating, I have to take care what is variable, because what the thing is inside R, inside D, is supposed to be the variable. The rest all things are constants. So only R is variable, X, M, everything, X, capital R, all are constants, so they will come outside. Now to integrate this is the trickier part. This you must have not seen in your life by now. It will come in class 12th. You have to assume, if integration is not, there is no general formula for the integration that is given to you, you assume things. Like I have done r square plus x square is equal to t, and that becomes this. Then I integrate. Then I have put such this one and then integrated. And then after that, at the end, I have put the value of t here. Small t, what I have assumed. Just look at this, how I have done, and see what doubts you are having. ज्यादा हो जा रहा है तुम लोगों के लिए क्वेश्चन। और इसको देखो, फिर मैं क्वेश्चन देता हूँ जरा।
So because it was a lengthy expression, we equated it with a variable. Then we integrated and solved that variable normally. And in the end, we input what we had taken as initially.
Yes, correct. That's what we have done. Which I'm giving in the question, just try to solve it. अरे did they teach all these things to you? No.
They didn't teach field in depth. very basic things they taught. Because sometimes they teach things in like part A level, and then later they take that up in part B.
Hmm.
So maybe they will teach them.
Hmm. Actually, one more result is there, but I think this will become too much for you. I have to give you one more result, field due to line of mass. But just before that, I want you to do one thing. After the class is over, no? After the class is over, just see this one once again. All the integration that I have done. Okay. Then I will do it in the next class. Because by then, the processing of this part will be done. You will be able to understand better. Okay. Now I'll start acceleration due to gravity. Let me give you the statement of this. Not this. This is a line of mass. We have to find out field at a point P, which is at a distance of r unit from it. This is making an angle of theta 1. This is making an angle of theta 2 with this. Okay. The mass is m, the length is L. The results, let me give you, the results are Ex and Ey. Ex is g lambda by r sine theta 1 plus sine theta 2. Integration part I'm leaving for the next. I will do it in the next class. I want you to process the above integration. Otherwise, it will become too much today. Okay, Diva and Kanishka.
Okay, sir.
Okay, sir.
Okay. These are the two results for the field due to this plane mass. Now let me move on to the acceleration due to gravity. Integration part we'll do in the next class. See, it's not that I don't want to do. I'm pausing it for the next class. Why? Because I feel it will become too much for you. Okay. Special cases are also there. Discuss in the next class. Achha. Now let me tell you about acceleration due to gravity. Achha, before acceleration due to gravity, I'll teach you one more thing about field. Did they teach you about Gauss law? Gauss law in gravitation.
Sir, I don't remember the name, but like when you teach, I think they did teach, but I don't remember name wise.
Okay, just let me write the expression, then you may remember. What's Gauss law? No? Gauss law is actually it's actually useful to find out the field for different kinds of masses, like solid sphere, or for hollow sphere, at different parts of a sphere, like that. Okay, what it says, suppose this is a solid body, correct? This is a solid body whose mass is capital M. We want to find out the field at 3 points. R greater than capital R. Other point is this. R is equal to capital R. The other point is inside. Okay. Now how we do it? How we apply Gauss law? The statement is line integral E dot ds is equal to minus 4 pi g into m enclosed. Did they teach you this? No.
No, sir.
But this law is actually very useful in finding out the fields. Let me teach you how. What we do, this is a solid, take it as a ball, solid ball. If you want to find out R greater than R, how we do it? This is a mass. We take a Gaussian sphere. This is a Gaussian surface. Gaussian surface is a closed surface, spherical, on which you will find out the field is always perpendicular to the area vector, correct? Now I'll teach you about the area vector. What is an area vector? If this is an area vector is actually perpendicular to it. Okay? Able to understand? Now see how we draw the Gaussian sphere. This is a Gaussian sphere. Gaussian sphere is drawn, or Gaussian surface is drawn at a point where we want to find out the field. Okay? And such that the area vector is parallel to the field vector. I'm not able to show you visualize. I'm not able to visualize, give you the visualization. If you take a ball, there is a ball, take a field, the area vector will be parallel to the field. This is the area. See, this is the area. Field is like this towards you. Area vector of this, my fingers are actually parallel to the this field. Able to see?
Yes, sir.
So E dot ds, this line integral E dot ds, this integral E dot ds represents the total for whole surface E dot ds taken. So it will be always, if you don't want to confuse yourself, just write E dot ds as E into 4 pi r square. 4 pi r square is the surface area of the sphere. Okay. Diva, okay? Tanishka, okay?
Okay, sir.
E into 4 pi r square means field into the surface area of the Gaussian sphere that you have taken. And this, what is this means? This will be equal to minus 4 pi capital T. This will be equal to, what is this M enclosed? This is mass inside the Gaussian surface. Now when you have taken this small r, this is mass capital M, solid one. Inside this Gaussian surface, how much mass is present? Capital M, right? Only this mass. Correct?
Hmm.
So we'll keep capital M. So the field at point P, what we have got? 4 pi will cancel. The field is E is equal to minus gm by r square. Correct? Understood?
So this is the original formula also.
This is the original formula also, but I'll give you the complex one also. This is one case when R is greater than R. Now, if we take the same case for E is equal to R, let me see how I do it. This is a sphere. Now I'll take, because I have to find out the field at capital R radius. So what I will do, I'll draw the Gaussian sphere at this radius only, here only. Pink line I have drawn now. This is my Gaussian sphere. Okay. Yes. So E dot ds will be E into 4 pi r square. Is equal to minus 4 pi capital G. What is mass enclosed inside? The mass of the sphere. So field is minus gm by capital R square. This you will be looking like, yeah, what sir is teaching. These are actually easy formulas that our institute has given. Yes.
Yes.
That typical thing will arise here when R is less than capital R. In this situation, this is your earth. Just wait. This is your solid sphere, solid earth, and you have to find out field at a distance r from it. Let me draw the Gaussian surface here first. Okay, Diva, Tanishka, we have to find out the field at this point, inside this sphere, at this point r, which is less than capital R. Total mass is capital M, means total mass of the given total mass of the solid sphere is this, total capital M. Now you have drawn, because you want field at this point small r, so E into 4 pi small r square. The problem is minus 4 pi capital G. What will be the M enclosed? M enclosed is the mass inside the Gaussian sphere. How you will find out the mass inside the Gaussian sphere? Can you tell me? To find out M enclosed, I will do, for 4 by 3 pi capital R cube volume, the mass is capital M. So for the volume of 4 by 3 pi small r cube, what will be the mass? M by 4 by 3 pi capital R cube into 4 by 3 pi small r cube. Is it okay?
Yes, sir.
So I'll put this value inside at this M enclosed and I'll get the result. So the result will be E into 4 pi small r square is equal to minus 4 pi capital G M small r cube by capital R cube. 4 pi cancel, small r square cancel with this. So E is minus capital G capital M small r by capital R cube. Understood? Here this Gauss law actually helps. I do not know any other method by which you can find out the field inside a solid sphere, gravitational field inside a solid sphere. This is Gaussian sphere. This is also a Gaussian sphere. And this is also a Gaussian sphere. Now just tell me you're able to understand this or not.
Yes, sir, I understood.
Understood, na?
Yes, sir, understood.
Okay, now let's stop it here because the acceleration due to gravity part, if I start now, that will go beyond. Now we have found out the field, and when we talk about acceleration due to gravity, they are nothing but field at different point. Acceleration due to gravity is represented by G. It is nothing but fields. Field for Earth. You know this one. Acceleration due to gravity is nothing but field on Earth. Correct?
Yes.
If we draw the Earth, this is your Earth, suppose, having mass m. You have to find out field at 3 points. One at a height h above it, one at a depth h below it, one at the surface. Let's say P, this is Q. Now since I said acceleration due to gravity is field at P will be what? Was gm by r square. But what is r here? Radius of Earth, capital R, plus h. Correct?
Yes, sir.
So the field at height h above the Earth is gm by capital R plus h whole square. Now field at Q will be what? So this is the value of G at P. Let's say G dash. Now if we talk about field at Q, this is
Zero.
no, this is inside the Earth is solid sphere, na? Earth is solid sphere, so you have to use that formula of field inside the Earth, inside the solid sphere. This one.
Sir, I thought Q was placing there. That's why it was zero.
Okay, na?
Yes, sir.
R will be capital R minus h, because if I draw correctly, this is its radius. So this distance will be r minus h. So the field at Q will be this, gm by r square into 1 minus h by r. Let's say it is G double dash. These are the results. Field on outside the surface. Acha, one more result is there. Field at let's say this point is R at surface. I'll just write this result and then end it. Field at R, which is at surface, will be what? Gm by capital R square was there. We write it as small g. So if we write the results in terms of this small g, how the results become? This becomes Gm by R square, I take common, 1 plus h by R whole square. So it will become G by 1 plus h by R whole square. Approximation we do as G into 1 minus 2h by R. This is one more result for this. You can write. And this one you can write as G into 1 minus h by R. But remember, this is acceleration due to gravity inside the sphere, inside the surface of Earth, means at the depth h below the surface. And this is at point P. And this is at the surface. Let me write, this is at the surface. This is depth h below, and this is at height h. You have to always use this formula, but when approximation is required, you can use this formula. This is when h, approximation is done when h is very much less than capital R. Then this approximation is done. Otherwise, you have to use this formula only. For depth h below, there is no problem. You can use this formula only. But remember, G, acceleration due to gravity, is nothing but the field. Okay, let's end it. Time is over. Next class, I'll give you the problems regarding this, and then we'll move ahead.
Bye, sir.
Bye bye.